let's review real quickly over the absolute and relative error situations that we had discussed. So in these cases, we wanted to give a measure of absolute error and relative error. So in this case, we're going to look at a situation where a new CPU microprocessor has a speed given as 800 megahertz, but the actual speed is 820. So in that case, what's the absolute and relative error? Well, here's how we're going to interpret what we have here. This 800 megahertz is what they claimed. The speed should be. However, the true value it turned out to be is the 820. So we'll do the absolute error calculation here by taking the claimed or measured value of 820 megahertz and subtracting away the 800 megahertz and subtracting away the 820 megahertz. That was the true value. And if we do that, we get negative 20 megahertz as the absolute error. And then if we want to do the relative error, what we'll do is we'll divide absolute error divided by the true value, and we'll want to write this as a percentage, so I'm going to write times 100. So that'd be negative 20 megahertz divided by the true value, 820 megahertz, times 100. Now if we do that calculation and we round to the nearest tenth, it comes out to be negative 2.5%. Okay, and now another thing we had discussed was accuracy and precision. And when we talked about precision, we meant how fine of a measurement can it take. And as far as accuracy, that meant how close of the measurement does it take to the actual true value. So if we look at these numbers here, they randomly select 4 parts, and the measurements are given here. And several different numbers that we have. And the length is supposed to be is 5.4523. So we want to answer the question, which is more accurate and which is more precise? Well, if we look through the numbers here, basically this one here, 5.11259, is more precise. Because this has a finer measurement to it. It also measures to more decimal places here. So it has more to work with as far as accurate, or as far as precision is concerned. For the more accurate, we need to compare the measurements to the true value to see which one is closer. So to do that, we can find the absolute error of each by subtraction. If we write out each, we do the subtraction of each just to verify which one has the smallest difference from the true value. Okie doke, and after doing the subtractions here, what we get would be this one, and this would be the difference between these two, and this would be the difference between these two, and then lastly this one here we'll notice has the smallest absolute error, and so this would be the more accurate measure. So we might see situations where it's more precise yet less accurate, more accurate yet in this case less precise. Here we're looking at a question that revolves around the relative difference between two values. In this case, it says humanities majors spend an average of $105 per course on books, and mathematics majors spend an average of $75 per course on books. So what is the percent difference between the two amounts relative to the amount for mathematics majors? So for this particular calculation, the way we do it is we say the compared value minus the reference value divided by the reference value. And since we're referencing the 75 for mathematics majors, that would be what that one will be equal to. And then this $105 is what it's compared against. So I'll use that value here for the compared value. And so when we do the calculation, it would look something like $105 minus 75 divided by $75. And we're going to make this into a percentage. I'm going to multiply by 100. So that turns into 30 divided by 75 times 100. And when we divide and do the calculation here, we'll get 40% as the relative difference. Now we're going to look at number 15a. And this one has again to do with percentages. It says if a motorcycle weighs 25% less than a car, then the motorcycle's weight is 75% of the car's weight. So the key words to look out for sometimes is less than or more than. If it's less than, then what we do is we take 100 minus the percentage to get the new percentage, or if it's more than, we add that number to 100. So in this case, we're doing, and that changes it from a less than to what we're having here where it says of, that is. So we're saying here that it's 25% less than. So what we'll do is we take 100 minus 25% or 75%. And that says 75% of the car's weight. And so that's how we can change it from one way to saying it the other way.